A claim has been spreading recently suggesting that Voyager 2 recently turned its camera back around and captured something that shocked the world. Before going any further, it deserves a direct, honest answer, because the actual history here matters, and getting it wrong misleads people about one of humanity's greatest scientific achievements. Voyager 2's cameras have not taken a single photograph since 1989, when the spacecraft completed its historic flyby of Neptune, its final planetary encounter before heading permanently out of the solar system. Shortly after that flyby, mission controllers powered down the camera system entirely, and it has never been reactivated since, for the same basic reasons that applied to Voyager 1's own camera. There is nothing left nearby worth photographing in the darkness of interstellar space. The software needed to operate the cameras was removed from the spacecraft's limited onboard memory decades ago to free up capacity for other instruments. And even if engineers wanted to reverse that decision today, doing so would require solving problems that have no realistic solution given the spacecraft's age and its enormous distance from Earth. So, no, Voyager 2 did not recently turn around and photograph anything. But something genuinely did shock scientists studying this exact spacecraft recently, a finding that resolves a nearly 40-year-old mystery about a planet Voyager 2 visited only once, and reveals that a planet most people think of as calm, distant, and boring was actually caught in the middle of a violent cosmic storm at the exact moment humanity got its only close look at it. This is the real story of what Voyager 2 actually discovered, decades after the fact, and why it changes how scientists think about this entire, still mysterious world. To understand why this discovery matters, you first need to understand the strange, decades-old puzzle it finally resolves. On January 24th, 1986, Voyager 2 became the first, and to this day, still the only, spacecraft ever to visit the planet Uranus, passing within roughly 50,600 miles of its cloud tops during a single flyby lasting only a matter of hours. In that brief window, Voyager 2 gathered essentially all of the direct, close-up scientific data humanity currently possesses about this distant, strange, sideways spinning planet, discovering 10 new moons, 2 new rings, and confirming a peculiar magnetic field stronger than Saturn's own. Among the data returned during that flyby, Voyager 2's instruments detected something that immediately puzzled the scientists analyzing it: unusually intense radiation belts surrounding Uranus, regions of energetic, trapped charge particles broadly similar in concept to the well-studied Van Allen radiation belts surrounding Earth, but considerably more energetic than anyone expected to find at a planet sitting so far from the Sun, receiving only a tiny fraction of the solar energy that reaches the inner solar system. For nearly 40 years, this specific anomaly remained genuinely unexplained. Scientists searching for the source of these unexpectedly intense radiation belts specifically looked for plasma, streams of charged particles that Uranus's 5 major moons, icy bodies broadly similar to moons found elsewhere in the outer solar system, ought to have been continuously venting into the surrounding space, material that could plausibly explain the elevated radiation levels Voyager 2 actually detected. That expected plasma simply was not there in the data, an absence that led an entire generation of planetary scientists to conclude that Uranus's moons were likely cold, geologically inactive, and essentially dead, a conclusion that shaped textbooks and research priorities for the better part of 4 decades, precisely because Voyager 2 remains the only spacecraft ever to visit this planet and gather this kind of direct data at all. In February of 2026, a team of researchers at the Southwest Research Institute published new findings in the journal Geophysical Research Letters that finally cracked this specific puzzle, and the answer had nothing to do with anything permanently wrong or unusual about Uranus itself. Instead, the research team determined that Voyager 2 happened to arrive at Uranus during an exceptionally rare temporary solar wind event, a burst of unusually intense energetic particles streaming outward from the Sun that struck Uranus's magnetic environment in the days immediately before the spacecraft's arrival, dramatically compressing the planet's entire magnetosphere and, in the process, injecting a substantial surge of additional energy directly into its radiation belts, supercharging them far beyond their normal everyday intensity. According to the research team's analysis, the specific conditions Voyager 2 actually flew through during its historic flyby occur only a small fraction of the time, meaning the single, unrepeated dataset that has shaped nearly 4 decades of scientific understanding about this planet was gathered during a genuinely unusual, atypical moment, rather than during anything resembling Uranus's normal, everyday magnetic environment. This specific finding draws a direct, illuminating comparison to a phenomenon scientists already understand well much closer to home. Similar solar wind-driven storms have been observed striking Earth's own magnetosphere on numerous occasions, and researchers have directly documented exactly how dramatically these storms can temporarily boost radiation levels within Earth's own Van Allen belts, sometimes by a considerable factor, before conditions eventually settle back down to their normal baseline once the storm passes. The Southwest Research Institute team's new analysis suggests Uranus experienced essentially the same basic kind of event, a passing solar storm temporarily supercharging its radiation belts at the exact narrow moment Voyager 2 happened to be flying past and taking its one and only set of direct measurements. The implications of this finding reach well beyond simply explaining an old anomaly, because it fundamentally undermines the confidence scientists have placed for decades in one of the most consequential conclusions drawn from that single 1986 flyby, the assumption that Uranus's major moons are geologically inactive, if the intense radiation belts Voyager 2 actually measured were primarily the product of a temporary passing solar storm rather than a stable permanent feature of Uranus's magnetic environment, then the absence of detectable plasma in that same dataset may simply reflect the same temporary disruption, plasma that had been actively stripped away and swept out of the system by the passing storm, rather than genuine permanent evidence that Uranus's moons never produce any plasma at all. In other words, the specific evidence used for nearly 40 years to declare these moons geologically dead may itself have been an artifact of unusually bad timing, rather than a reliable reflection of how the system actually behaves under normal conditions. This is not a minor academic correction. Icy moons that show evidence of ongoing geological activity, venting material into the surrounding space the way similar moons at Saturn and Jupiter are known to do, are treated as considerably more scientifically compelling candidates in the ongoing search for potentially habitable environments elsewhere in our solar system, compared to moons confidently written off as cold, dead, and completely inert. For nearly 4 decades, Uranus's major moons sat firmly in that second, less compelling category, based entirely on a single, brief flyby now understood to have captured genuinely atypical conditions. This new research does not prove these moons are actually active. It does something perhaps more important for the honest practice of science, removing the specific evidence that had been used to confidently rule that possibility out in the first place, reopening a question that had been treated as essentially settled for the better part of 40 years. It is worth being precise about exactly what remains uncertain here, since that precision is exactly what separates genuinely significant scientific progress from manufactured, exaggerated claims. Nobody involved in this new analysis is claiming to have directly detected evidence that Uranus's moons are geologically active. What the research genuinely shows is considerably more measured, and in its own way, more scientifically important, that the original evidence used to declare those moons inert was gathered under conditions now understood to be unusual and temporary, meaning the confident conclusion built on top of that evidence no longer holds the weight it once did. The actual answer to whether these moons are truly active remains genuinely unknown, and will likely remain unknown until a future spacecraft is sent back to Uranus to gather fresh, independent data under a broader, more representative range of conditions, rather than relying on a single brief snapshot captured by chance during one narrow, now recognized to be atypical window in 1986. This connects directly to a second related mystery about Uranus that has also drawn renewed scientific attention recently. In September of 2025, a study using computer modeling revealed that Uranus, contrary to decades of prior assumption, actually emits measurably more energy than it receives from the Sun, overturning an earlier belief that this particular planet was uniquely lacking in any detectable internal heat compared to every other giant planet in the solar system. Combined with the newly understood context surrounding Voyager 2's radiation belt measurements, this finding reinforces a broader pattern emerging from recent research, that Uranus is a considerably more dynamic, more active, and less thoroughly understood planet than the single, brief dataset gathered during its only ever spacecraft visit had led scientists to believe for the better part of 4 decades. Even the discovery of Uranus's moons has continued well past Voyager 2's own flyby, with astronomers using the James Webb Space Telescope announcing the discovery of an entirely new tiny moon orbiting the planet in August of 2025. A small object only about 6 miles across that had gone completely undetected by Voyager 2's own instruments back in 1986, bringing Uranus's confirmed moon count up to 29. Taken together, this accumulating body of evidence makes an increasingly compelling case for exactly the kind of dedicated follow-up mission planetary scientists have been advocating for years. The National Academy's most recent Planetary Science and Astrobiology Decadal Survey specifically identified a dedicated Uranus orbiter and atmospheric probe as one of the highest priority large-scale missions for NASA to pursue over the coming decade. Precisely because so much about this particular planet and its system of moons remains genuinely unresolved, resting entirely on data gathered during a single, brief, and now recognized to be atypical flyby nearly 40 years ago. Researchers involved in this new radiation belt analysis have been direct in stating that their findings reinforce exactly why this planet deserves another visit, since so much of what scientists currently believe about Uranus rests on a single dataset now understood to have been gathered under genuinely unusual, non-representative conditions. Step back and consider what this entire episode actually demonstrates about how scientific understanding evolves over time, because it reveals something genuinely important that extends well beyond Uranus itself. For nearly 40 years, an entire generation of planetary scientists worked from a specific, confident interpretation of what Voyager 2 had found during its brief 1986 flyby, an interpretation that shaped textbooks, research priorities, and the broader scientific consensus about an entire planetary system. That interpretation was not the result of careless or sloppy science. It was the most reasonable conclusion available at the time, built from the best data anyone actually possessed. And it turned out to be built on top of a genuine, unrecognized coincidence, a rare, temporary solar weather event that nobody analyzing the original data in 1986 had any way of identifying, simply because the comparative context and the decades of additional solar wind research needed to recognize this specific pattern did not yet exist at the time. This is precisely why old spacecraft data, gathered decades ago by a mission that will never fly again, remains genuinely valuable for active, ongoing scientific research today. Voyager 2 has not visited Uranus in 40 years. It never will again. And yet, the data it gathered during that single brief flyby is still, right now in 2026, actively being reanalyzed, reinterpreted, and used to overturn conclusions that had stood essentially unchallenged since the moment they were first published. Somewhere in an archive, decades-old measurements are still capable of producing genuinely new scientific results, provided the right researchers, with the right new tools and the right new context, eventually go back to look at that same data with fresh eyes. So here is where this genuinely stands right now in the middle of 2026. Voyager 2 did not recently turn its cameras back around, and it did not capture any new footage of anything at all. What actually happened is considerably more scientifically significant than any invented myth about a spacecraft's cameras suddenly reactivating decades after they were shut down. Scientists studying data, this same spacecraft gathered nearly 40 years ago, have determined that Uranus's unexpectedly intense radiation belts, one of the strangest unexplained puzzles in all of outer solar system exploration, were very likely the temporary product of a rare solar storm that happened to strike the planet at the exact moment Voyager 2 flew past. An explanation that simultaneously calls into question one of the most consequential conclusions ever drawn about this planet's system of moons, whether they are truly inert or whether they have been quietly active this entire time, waiting for a future mission to finally check. If you want to know when a new mission finally returns to Uranus, and whether those 5 distant moons turn out to be quietly active after all, subscribe and turn on notifications, because this is a genuine mystery still waiting for its answer, and the only spacecraft that has ever been close enough to check left us with a single, now understood to be unusual, snapshot nearly 40 years ago.